As you guys just heard, I'm the CTO of a company called Levanto Financial. We help people with their budgeting. I build video courses for a site called frontendmasters.com. This is the site where we just raffled off 2 memberships. Check it out. Great courses there. My perspective is I'm a product guy who happens to code, right? So I don't really get as excited about making something a little bit faster compared to getting something in the hands of customers faster and building things quickly and iterating quickly. I do a lot of JavaScript open source stuff, and I don't just work with one framework. I kind of touch on everything. And that's part of what I want to talk to you about today. So we've got all of these different JavaScript frameworks. In fact, I think 2 or 3 just came out since I started talking. But they're all trying to solve the same problem. And that is that we're trying to build rich applications on top of a document viewer. If you think about the oldest browser that you have to support, it doesn't really give you much compared to what you would have if you built native iOS apps or desktop apps, where the primitives, the smallest building blocks you have, are much more advanced than something like a div or a span. And so whether you're using Angular or Ember or Meteor or React, all of those are trying to give you a better foundation so that you don't have to do all of that low-level work. And things are getting better. So who in the room has used web components before? Okay, this isn't such a trick question for anyone that was in my workshop yesterday. This thing that we all have been using is really this, right? So we've got a placeholder here for full name, and down here we can see that it's actually placed inside a div that's inside something, beneath the input component there. And where we're going with this idea of native web components, which is something that we will see in the browsers in the future. The idea is you should be able to make something like this. And I'm sorry if the colors aren't working too well here, but you want to have your own vocabulary in HTML that is connected to the idea your app is trying to solve, the problem your app is trying to solve, so that you can read it more easily, right? So if we have a presentation with slides in it, it's better to look at this compared to this. Talk about a difficult program to compile. I don't know what we're looking at here, and this makes for bad times. So when we talk about the W3C web component spec, W3C, that's just the group of people that decide what is HTML, what is the DOM API. They decide what things are added, where it's going. It's actually 4 pieces put together. So you've got first HTML imports, and you can think of this as just a link or a require. It's the ability to bring an HTML file into your app the same way you bring a style sheet into your app or a JavaScript module. Just like with link tags and with bringing in external resources of other kinds, you have feedback as to whether it worked or didn't. Because it's HTML and HTML has support for embedded pieces of JavaScript and style, you can really get style, structure, and function, right, in the form of CSS, HTML, and JavaScript, all in one file, all imported at once. And you also get some closure-like JavaScript characteristics. And what that means is, if you write a function, stuff inside the function can see other things inside the function, but it can also see things outside in the outside world. So you get some things like that. So the second piece, custom elements. This is the ability to add your own vocabulary to HTML. So you don't have to say div, 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 div all the way down. You can say this is a card. This is a contact information widget. Custom elements also give us a life cycle, so we know when a component has been created, when it's been inserted into the document. It gives us extensibility by way of prototypical inheritance, the same way that you can extend object, you can extend these components. And the hope We're not there yet. Polymer doesn't get us there before anyone jumps to that conclusion. The idea is that the components you make can be used with any framework you want, just like you can use input, or you can use text area, or you can use div. They should just work underneath any of your favorite tools. HTML templates, this is the only piece of the 4 that is actually supported in all browsers. So this is part of HTML5. HTML templates allow us to place inert HTML in the DOM, and inert just means the browser doesn't try to read it. You know, if you have an image tag and the browser reads it, it's going to immediately go and try to fetch that image. Or if you have a script tag with, you know, linking to an external script, you'll start downloading that and you'll start evaluating that code. When we say inert, it means it's there, but the browser does nothing. Nothing until you start doing something else. So this allows us to do lazy loading, sort of, right? It allows us to have something there and to say, when I use whatever this template does, go and fetch these resources that are required, and it will do that just in time, just as you need them. If you've used handlebars or Jade templates, this was the pre-HTML5 way of solving this problem, right? Where you have maybe something inside a script tag that looks like HTML, and because it's not a JavaScript script tag, the browser sort of ignores it. It's there, but it does nothing. And the last and most complicated piece of this, and probably the thing that's holding up broad availability of web components, is this concept of a shadow DOM. And the shadow DOM was, if you think back to the input component that I showed you, it is the insides of the input. It's the fact that we have an editor that you can write in, and you have a placeholder that has the full name, you know, the HTML attribute for placeholder on the input. And the concept here is each component has its own subtree. Just like your document has a subtree, each component has a little mini document inside of it. And we'll explore how powerful this is, but it really lets us solve some big encapsulation problems, particularly around CSS. CSS is not fun right now because we're programming with globals. Everything is a global in CSS. You have the potential to affect things all the way down, inside components, all the way down, unless you have this concept here. So you put them all together, and we say, this is what it means when we say the web component spec. It's these 4 things. And currently, if you wanted to play with them, you can do it in Chrome. You've been able to do it in Chrome for a while. You can also turn on a flag in Firefox, but nowhere else can you really start using this today. The hope is in the future, this will be just like, you know, a div. It will be available everywhere. So what we're going to do now is we'll dive deep into each of these areas, and I'll show an example where I can of code you could write in Chrome today to make web components without any framework. But then I'm going to talk about how 3 frameworks align with this web component spec. And hopefully we'll start to see how we're sort of building on the same concepts that will come for free in the future, right? Whether you're using Angular 2 or Ember or React, or we'll even see some Angular 1 parallels, those things that we like to use there, they are informing where we'll be able to go without any libraries in the future. So this concept of HTML templates, pretty easy. It just looks like this, right? Where you have the template tag, and it has an ID or a class on it so that you can refer to it later. So you can grab it and you can do something with it. And inside is HTML. And because we can use any HTML, we can make it more interesting, and we can have some style, and we could have some JavaScript. I haven't written any, but it would be very easy to add some there. And that would all pertain to this component here. Now, JavaScript that is in here can interact with the DOM of this template and also the application that it was imported into. So the way we would use something like this is we would write a little bit of code that kind of starts with this document.import node function, and we're going to just pass the template's content into it. And the template's content just comes from using a query selector or jQuery or whatever you need to use. And then we just append it to something. So we're basically grabbing it, calling this import node method to create a document fragment, just like if you were creating divs or spans or images with JavaScript. This works exactly the same way. So I'll post my my slides after the talk. I've got a bunch of CodePen examples that work, and I'm just going to show you screenshots for now. But here is proof that it works. We've got a template with an ID. We grab the template by the query selector. We access this content property here, and then we just append it directly to the body. And you can see, even though we imported this template and it was inert before we ran our JavaScript, once we import node and append child to the body, we start to see hello world there. Very, very simple concept. You guys are probably using something similar today. So how do the frameworks we like do this right now? Well, they're all built around a similar concept, and that is at build time, your HTML or your handlebars or your Jade templates, they're transformed into JavaScript modules. And it's a good thing that this is all done behind the scenes, because nobody wants to read this. All you need to know is underneath, these are imperative instructions for building some HTML. And you can call this function, usually in the context of some data, so that you can have placeholders for data and you get HTML out. So we have these JavaScript modules, and sometimes we have optimizations where we can make this into a big string, the whole JavaScript module, so that it's just kind of sitting there as a string. We don't even have to spend the time to parse it, right, which takes some time in the browser, until we really need that template. And then we do eval and then pass the string in, and now we can use that template and we can build our HTML. So in Ember, this concept of lazy loading, right, lazy loading of resources, this is a big benefit of having something that is inert. We use something called engines for lazily loading big chunks of our application. And this idea of having strings, JavaScript in string form, before we transform it into code, this is something that's landing soon in the next release of Ember, which should be in about 3 weeks. And we call this the just-in-time template compiler. Angular and React are both built on top of Webpack. Usually that's the standard build tool to use. And they use this concept of chunking to achieve this kind of modularity and lazy loading of pieces of your application. So that's HTML imports and lazy loading. So let's jump into Shadow DOM. The concept here is that you have your application DOM, which you're used to working with, right? And then you have an element that represents the boundary of your component. In the case of input, it would be that input tag, right? Where that's sort of that's where you cross the line to the inside versus the outside world. And everything inside, everything that's in that shadow root, is part of the Shadow DOM. So this gives us some interesting CSS encapsulation here. And you can see that I've hidden the JavaScript here, but I've got a paragraph tag here that's just in the application DOM. I've got a template here, which, remember, does nothing until we create a component. The JavaScript is basically the same as what I was showing you before, but the key here is that we've got some style that affects all paragraph tags. And you can see, hopefully the stage is not cutting things off, but you can see that the application DOM, this paragraph tag, this is colored red, and this other one is not, despite the fact that it would match. If we did not have a shadow root, we would see that this style applied to all paragraph tags. But the shadow root has kind of stopped this rule from going inside the component. This is a very powerful concept, because right now we write our CSS, we manage it the way you would manage anything that is just a big pile of globals, We're very specific about CSS rules. We use namespaces and prefixes to stay organized, but often we still end up accidentally affecting things that we didn't mean to affect. This would let us write very simple rules because we only have to worry about the inside of the component, and then our application CSS has to do less and less. It doesn't have to be responsible for styling the components themselves. So as we've seen, usually CSS does not go into the shadow root. Anything that is part of that HTML import, for example, anything that's part of that template, like a style block inside the shadow root, that will apply to all of the DOM in that shadow root. And then we have a couple tools that we can use to pierce through the shadow root if we need to. Host is a way for component CSS to kind of style the wrapper of the component. So this would mean like you could style the input tag from stuff that's inside of the shadow root of that component. This shadow selector is used to go into the shadow root deliberately, and it lets you kind of punch through and have application CSS that will sort of reach into one shadow root. There used to be this idea of a deep pseudo selector, which is down here, it's /deep. That has been deprecated. They decided this was a bad idea, and that is because it penetrated all shadow roots all the way down. It essentially made it so the encapsulation, you could accidentally kind of erase the benefits of this encapsulation. You can still use shadow over and over, but you have to be deliberate, like you want to go three shadow roots deep, you know? So you have to be a little bit more explicit. But here are examples of how you might use those kinds of things. So how do we handle this in frameworks, this idea of CSS encapsulation? Well, in the Ember world, it comes in the form of libraries, and there are two schools of thought. The first one here basically randomly generates a base 64 number, and it will rewrite your CSS so that it sort of scrambles the class names. And this ensures that a CSS file that is specifically for a given component will not affect anything else because we're sort of adding random numbers to CSS class names. It doesn't make things incredibly readable, but it does give us more assurance that we're not going to accidentally hurt ourselves. There's also this idea of component CSS, and for that, I would suggest you go and look at CSS modules. It's an idea about having, you know, modular CSS where you have one file per component, and all three of these options actually have support for that via libraries. Angular is because it's newer and because they have the advantage of working with the Polymer and the Chrome team, they're able to align a little bit more closely with web standards, and so they use component styles, which means they can actually use this shadow pseudo selector, and they can use the host pseudo selector right out of the box. And React CSS modules, that works similarly to what I just described in Ember, but with React. You probably don't need any of these anyway, because as we all know, CSS is awesome. So another aspect of web components that relates to the shadow root is this idea of content projection. And what this means is we've got attributes and things that are expressed in your HTML for your application, and they have to make their way into the components the components DOM itself, right? And so here we can see we've got the placeholder with full name. It has to make it here, and keeping those in sync is it's something that would be nice to have the framework do for us, or have the foundation do for us, instead of having to implement listeners and then explicit DOM updates. You know, we try not to do that anymore. Here's another flavor. And by the way, these down here, this is the way Chrome treats these components. This is the shadow DOM of a text area. And you can see we've got a body here. We've got a body of the text area, and it ends up being placed inside the shadow root. So how does this happen? You get a special content tag here, and you can see here we're using it twice. we're using it once up here with this select attribute, and then once here with no attributes. And what we can see is that, sorry, my example's cut off a little bit at the bottom here, but what's happening is we're creating an instance of this component, and this is sort of the wrapper of the component, because we haven't talked about custom elements yet, so I can't give it a nice, semantic name. But we've got one thing that has a class called h1, and then one thing that doesn't have any class on it. And so what's essentially happening here is we're running like query selector based on whatever the value of that select attribute is, and we're plucking that out, and we're able to place it inside an h1 tag. And that's why when you see the word good here, although it's just in a span, it ends up being placed inside this h1 tag. So we're kind of plucking it out and we're placing it where we want it. And then this is a catch-all. Anything that hasn't been specifically plucked out and placed, that will end up being where your content tag is. And that's where you would see hello world. It's cut off by the bottom of the projector here, but it is there. So how does content projection work in our favorite frameworks? In Ember, when we use components, we have this concept of yield, and it is just like the way content works, right? The body will be placed wherever you have yield. Angular 1, if any of you have used that, ngTransclude is a great way of having a slot-based content projection where you can have named slots, and then you can sort of transclude content into the right place. Similar concept in Angular 2, except they're trying to align with the web standards a little bit better. They don't use the word transclude anymore. They use ngContent, and it basically does the same thing. In React, usually you're going to use this.props.children when you're implementing your render method and you have the stuff that looks like HTML in your JSX file. This is where child components will be rendered. So this is content projection. And you can see that we're trying to, we have these needs when we're building our application. And the idea is that this web component spec is being built so that it will support us in the same way that our frameworks do. Because we need these things in order to have expressive, HTML or expressive handlebars or expressive JSX. So the third area I want to talk about, and this is a really easy one, it's HTML imports. This is the one that you can actually, oh no, this is not the one you can use today. That was HTML templates. This one is supported in Chrome and Firefox. If you turn a feature flag on, it just looks like this. Pretty easy to understand. The way you use it is first you get the document fragment off of whatever you imported, just using this import property here. And then to use it, you will, actually this is going to give you the document fragment itself. This down here is sort of a separate example showing that anything that's written in a script tag inside the HTML that was imported, that has the ability of either running the script in the context of the imported HTML or the outer application. And you can just sort of traverse the links between the documents in order to get one or the other. How do frameworks handle this? Well, because we don't really have this HTML import supported broadly yet, we have to use JavaScript. So we all use this. Our components are transformed into JavaScript, usually both the behavioral part of your component and the HTML-ish part of your component. Those both become JavaScript modules, or in the case of React, one big module, and you just import it and you go. So the final part here, they are custom elements, and this is where we can take everything we've talked about so far, and we can put a name on it so that we can have a nice expressive semantic way of declaring the structure for our app. And I'd like to pause here and talk about why this is an important last piece of the puzzle to put in, because it might seem like it doesn't add much, but this is kind of where all of the important magic happens. So the first thing is we get composable building blocks. Naming the component, being able to have specific types, and to be able to use those in HTML, that is what lets us get away from div soup. Div, 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 div. This is what solves that problem. Having a JavaScript object behind what you're using in your HTML, and they each, the ones that you use today, they each have a JavaScript component as well. A div actually has a JavaScript representation, if you haven't explored that yet. But because we have JavaScript there, we have a life cycle. We have hooks that we can use to do things when the component's instantiated, when properties change, when it's inserted into the DOM. And these are very important. Like if you run a jQuery plugin and you want to wrap a component around it, you need to make sure that that stuff is in the DOM before you run the plugin, or it's not going to work. And finally, I think that, so we do get extensibility like you do with any hierarchy of JavaScript types. But I think the main win here is you get to write HTML that is much more closely related to the way you think about your problem, right? You can just say presentation, slide, 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 and it's very easy for someone else to come along and read that and understand what you're trying to do and what this represents. So the way we deal with custom elements, the first thing we have to do is we have to register it. And we start by basically cloning an existing DOM element and giving ourselves a prototype that it's basically the constructor of this DOM element. So this will serve as the prototype of what we're about to build. We then create, and we register the element type by passing in this object here that begins here. We say, here's my prototype coming from up here, and it extends this button tag. So you have to do that twice because this here, this is the JavaScript representation. This is the HTML tag that is related to that JavaScript representation. You have to specify it both ways. And then you can use your new tag, right? And this would allow you to have angle bracket mega dash button instead of just button. So to make this more interesting, I'm going to add a little more complexity here, and we're going to use our HTML template. And I just want you to focus on this first, where we're grabbing our template, just like we were before, right? We're just using query selector, we're grabbing something from this template. And then here, we're going to create a shadow root, and to the shadow root, we're going to append something, and that's just going to be document import node and then our template. And that's it. And now we can have a template and a named custom element type associated with that template. And every time we create a new, HTML declaration of this new element we've created, that template is going to be cloned and added to a brand new shadow root, and you have a custom element. So how do frameworks handle this? No surprise, this is where we're talking about components. This is basically the whole idea behind React. This is the Reactness we're talking about. Angular has this annotation called component, and Ember has a JavaScript class called Ember component. They all provide the ability to have a name that you can use in something like HTML, and they give you a life cycle. So I'd like to wrap up here by showing you a little demo of native web components and what you can do. And our demo today is going to be a hamburger menu, right? Common use case here. So let me see if I can switch these up here. Does this work? Can you guys hear me? All right, so this is all on CodePen if you want to check it out later. I'm going to show it to you in 3 steps. The first is going to be, oh, thank you. Nothing interesting yet, but. I know what to do, just one moment. Yeah. Yep. All right. I have a backup plan, don't worry. Windows. I wonder why. Oh, come on. It's just a resolution thing. Gather Windows. It's just it doesn't like scale. 720. Nada. Oh, wait. Let's see if we can get. Let it go. Whew. What is happening here? Oh, there we go. All right. So, let me find where this is. Okay, so here's the first example. We've basically got a bunch of divs here. Um, note, you can see we have no HTML template yet. You don't see the template tag. I'm going to hide the style here because that is not the point of what I'm showing you. And in the JavaScript, we are basically adding. We have some code that will add a class and allow CSS to animate the menu going open and going closed based on whether a class is present on the menu itself. You guys have probably done something like this before, right? You add a class and then you use a CSS3 transition, and it works, but it's not incredibly easy to read. We've still got divs everywhere. So this is the starting point. This is where you would say, all right, I've got a building block here. I want to use a component instead because maybe I've got 3 apps that all need a hamburger menu. So here, what we're going to add to it is we're going to take all of that style, right? This is all of our CSS. And you can see this is really unimportant at this point. There's nothing in our application CSS. We've got a style block here with what used to be in the CSS window. And then we've got all of our divs. Here's our content tag here. And you can see that this is, so I've got actually 2 components here. I've got a hamburger menu, and then I've got a hamburger menu item. And then down here, I'm able to, if everyone can read that, I'm able to describe my menu, not using divs, but using something that's much easier to read. Everyone looks at this and they know it's a menu, and they know these are items in the menu. And so when they see it come out like this, it's very easy to see that like serious bugs ended up here. Really serious bugs ended up in the next item. So it's much easier to reason about. So the third step is to take all of this component stuff that we've built, put it into a single HTML file, and then import that HTML file into our app. So now we've kind of wrapped it up. Maybe we throw it on a CDN somewhere so we can download it just like a JavaScript file. And we will end up with this. So here's our HTML input. And then right away, we can start using this component. We don't have to have a template because that's all inside this HTML file that I put up on S3 so we can download it. Oh, and apparently it's not up on S3 anymore. It would work, except this link must have expired or something. But this is the general idea here. No JavaScript, very little CSS. We're able to import an HTML file from the outside world, and then right away we can start using these components. So this is the future. This is where we hope we can go. And what this means for your favorite framework or your favorite library is they will just end up doing less, right? They'll end up helping you efficiently create a component rather than being responsible for managing a huge bunch of divs. And when you inspect element, you'll be able to actually see your components in the DOM with their shadow root. It won't be this idea of we're building components in development mode, and then for people that use our application, it's back to the 1999 way of treating interactive web applications. So that's all I have. Thank you guys for listening. I will post this demo. It's like 7 steps building up to this point on my Twitter handle. So make sure you follow me. And thanks a lot.